Hello everyone, welcome back. In this session, we will discuss about we will discuss about ARP protocol. We already discussed about ARP protocol in our previous sessions. But in previous sessions we discussed ARP within the network. Now we are going to discuss about how this ARP works between the networks. For example, so here 192.168.1.2, 192.168.1.3, 192.168.1.4, and 192.168.1.5. These four computers are same network. If you send data from PC2 to PC5, if you send data from PC2 to PC5, PC2 required PC5 MAC address. If PC2 doesn't know PC5 MAC address, PC2 sends ARP request, right? ARP request. How this PC generate the ARP request? So now I will discuss, okay, from starting. Okay, see here. For example, I am pinging from PC2 to PC5. Okay, now see here, understand clearly. I am pinging from PC2 to PC5. So what happened here? When you enter this command here, which command? Here, when you enter this command, ping 192.168.1.5, for example. So when you enter this command in command prompt, so what happens? So we already discussed this, right? So what happens here? When you enter ping 192.168.1.5 in command prompt, so actually what happens? What this PC actually does? So here destination IP is 192.168.1.5 and the source IP is 192.168.1.2, right? The first to this PC checks destination IP is same network or not. Destination IP is same network or not. That is the first step, right? Whenever you enter this command, the first PC checks whether this IP is same network or not. So first PC find out whether this destination is same network or not. So now here this IP is the same network 192.168.1.5. How this PC find out whether it is same network or not? Same here, this PC perform end operation. This PC perform end operation. But how this perform end operation? Now see here. What is the destination IP? Destination IP is 192.168.1.5 and local mask is what? Local mask is 255.255.255.0. Destination IP and local mask. Destination IP this one and this is local mask. So router PC perform end operation, okay, with these two IP and subnet mask. 192.168.1.5. So what is the binary? 192 means 11000000. This is 192. 168 is 1010100. This is 168. And 1, this is 1. And 5, this is 5. And mask 255 means all ones, and 255 means all ones, 255 means all ones, and 0 means all zeros. Now perform AND operation. 1 1 1 1 1 1 0 1 0 0 0 0 0 0 and 1 0 1 0 1 1 1 0 1 0 0 0 0 0 0 and here 0 0 0 0 1 and here all zeros. Now convert again this binary number into decimal. This is 192 and this is 168. This is 1. This is 0. See, network ID is 192.168.1.0. So which means PC can understand, okay, destination IP is same network. This is the process. Whenever we enter this command, ping command, not only ping command, whenever we are sending any data from PC to another PC in the same network or different network, whatever it may be, the first source PC checks whether destination IP is same network or not. So how it will checks by performing AND operation. So in the AND operation, what it will use? It will use destination IP address and local subnet mask. Remember this point. Then it will find out the network ID. Okay. So now here, this PC find out the destination IP is same network, right? Then what happened? To send the packet here, right? So ping packet is what is the packet? Ping packet means ICMP packet, right? So to send the ICMP packet, ICMP echo request, right? Echo request. So in the echo request, what is the source IP? The source IP is 192.168.1.2 and what is the destination IP? Destination IP is 192.168.1.5 and source MAC is what? Source MAC is PC MAC address, PC1 MAC address, for example, PC1. And what is the destination MAC? For the first time, this PC doesn't know, right? What is the destination MAC address? Because, see here, here we have entered only IP address, ping 192.168.1.5. We have not entered any MAC address here. So, here the first of this PC checks its ARP table, checks its ARP table, whether I have a MAC address or not for 192.168.1.5. For examples here, how to check the ARP table? Command is ARP space -A. See, in ARP table, there is no any entry for 192.168.1.5 because to send this ping packet, ping packet, this PC should know MAC address. Otherwise, it cannot send packet. But how this PC will find out the MAC address? So before sending this ping packet, the first PC generates the ARP request. First PC generates ARP request. In ARP request, okay, see here, ARP request is also one kind of packet, right? So in ARP request, what is the source IP? The source IP is 192.168.1.2 and destination IP is 192.168.1.5 and the source MAC address is PC1 MAC address, for example PC1. And what is the destination MAC address? Destination MAC address is, and here destination MAC address is broadcast MAC address FFFFFFFFFFFFF. This is the ARP request. The first PC prepare ARP request. In this ARP request, the source IP 192.168.1.2, destination IP 192.168.1.5, and the source MAC is PC1. PC2, right? It's one. Sorry. Here okay, PC2. Sorry, PC2, and here also I will put PC2. Okay, PC2 and destination MAC address FFFFFFFFFFF. This is the broadcast MAC address. The first PC sends this ARP request to switch. Switch will flood this ARP request out all interfaces. Then what happened? This ARP request is received by PC3, PC4, PC5 and also router also. But PC3, PC4 and router will simply drop this ARP request. PC5 will respond. PC5 will send the ARP request to PC2. right? After getting ARP replay, then what happened here? PC2 will PC2 will PC2 will fulfill MAC address in ICMP echo request like PC5, and it will send the packet to destination. Now I will show you here. I will show you practically here. You can easily understand here. So to see here packet level in Cisco Packet, we have a feature. So here in the right side, we can see simulation. Simulation means actual traffic. It is acting as a actual traffic, actual network. Okay. See enable simulation, and now ping. Okay. See I am ping 192.168.1.5. Ping 192.168.1.5. Enter. See PC prepared two packets. One packet is ICMP packet. One packet is ARP packet. The green color packet is ARP and the blue color packet is ICMP packet. If you open this ICMP packet, just click on blue color packet. See here, layer 3 is there, IP address information is there, but in the layer 2, there is no source MAC address, destination MAC address. Source IP is 192.168.1.2. Destination IP is 192.168.1.5. But there is no any layer 2 information. Means there is no source MAC address or destination MAC address because this PC doesn't know right now. See here, this is a ARP packet, right? Now open ARP packet. See, in ARP packet, source IP is 192.168.1.2, destination IP is 192.168.1.5, and the source MAC address is the PC1, PC2 MAC address, and the destination MAC address is what? Broadcast MAC address, FFFFFF dot FFFFFF dot FFFF. This is ARP request. So first this PC sends this ARP request to switch. Here see, first PC sends this ARP request to switch, right? So now here in below we can see play controls. Play controls. If you click on play here, the packet will move. See, click on here, right? Like that. And again click one more time. See, packet. Switch send packet all devices. Router also. Router, these three computers. But see, router drop packet. PC3 also drop. PC4 also drop. Only PC5 accept. Now again click on one more time here, capture here, right? Now this is the response. Now see here. Now if you see ARP table, now okay, wait, okay. See here, now it will send the ICMP packet. This is the ICMP packet. Now it will send ICMP packet. Ping packet. See, this is the ping packet. This is how ARP works within the network. Again, click on real time here. In the right side, click on real time. Okay, don't forget. Okay, real time. Now see ARP table. Earlier there is no any entry right in ARP table. ARP space -a. See 192.168.1.5 and MAC address. MAC address added. Okay, this is within the network. How ARP works in same network. But now we will discuss how this ARP works between the networks. Between the networks. I will send packet from PC3 to here. I will send packet PC3 to this PC3. I will change your PC names like you can easily understand. This is the PC6. This is PC7. And this is PC8. And this is PC9. Now I will send packet from PC3 to PC7. PC3 IP address is 192.168.1.3. PC7 IP address is 192.168.2.3. Now PC3 and PC7 both are different networks. PC3 is belongs to 192.168.1.0 network. PC7 is belongs to 192.168.2.0 network. But how this PC will forward packet to PC7? For example, if I enter the same command here in the PC3, ping 192.168.2.3, right? 2.3. What happened here? The first PC checks whether destination IP is same network or not. This is a common thing, right? The first, whenever you send anything from PC, the first PC checks whether destination IP is same network or not by performing AND operation. Okay, now this destination IP is different network. Now here, see, the first PC pack prepare the packet ICMP packet, right? In the ICMP packet, the source IP is 192.168.1.3 and the destination IP is 192.168.2.3. 2.3 and the source MAC address is PC3 MAC address. And what is the destination MAC address? What is destination MAC address? Tell me, what is the destination packet? Because now the destination is different network. Destination is different network means this PC cannot reach directly to destination. This PC cannot ask what is your MAC address, please provide your MAC address, like that. ARP works within the network. ARP works within the network. As ARP will not work between the networks. Remember this point. Means ARP packet will not cross boundary. Remember this point. But how this PC will send this packet? Very important interview. Now I am sending packet from PC3 to PC7. PC3 IP is 192.168.1.3. PC7 IP address is 192.168.2.3. Now both are different networks. So if PC3 wants to send this ICMP packet, in ICMP packet should have source IP, destination IP, source MAC address, destination MAC address. But now here, what is the destination MAC address? How this PC sends this ICMP packet? How this PC will find out the MAC address, destination MAC address? Now very simple here, okay? Very simple here. Listen carefully. So the first PC checks whether destination is same network or not, right? If destination is belongs to different network, then PC immediately checks what is my gateway, because PC can reach that network through gateway only, right? That is the purpose of the gateway. So what is the gateway here? We already configure, right? See here, gateway IP is 192.168.1.1. 1.1. So this PC simply send this packet to gateway. Right? Gateway is the mediator here. Gateway is responsible for sending traffic from 1.0 to 2.0. Right? But now here, so this PC understand, oh my gateway is 192.168.1.1. So I need to send this ICMP packet to 192.168.1.1. Okay, my source IP is 192.168.1.3. Destination IP is 192.168.2.3. The source MAC address is the PC3 MAC address. But what is the destination MAC address? Destination MAC address is gateway MAC address. Because this PC is sending packet to first gateway. So that's why here this PC use gateway MAC address as destination MAC address. Remember this point, very important. Because this PC cannot send packet directly to 192.168.2.3. This PC sends this packet to 192.168.1.1, right? 1.1 is the mediator. So to send this packet to 192.168.1.1, this PC required 1.1 MAC address. 1.1 MAC address. If this PC doesn't know 192.168.1.1 MAC address, again this PC will generate the ARP request for getting MAC address of 192.168.1.1. Remember this point, very important. Now see here, if you see the ARP table, ARP space -A. See, there are no any entry, right? No entries. There is no MAC address for 192.1.1 also. Now here see, I will enable simulation again, and here I will enter command ping 192.168.2.3. right? Now see, PC prepared two packets. One packet is ICMP packet, one packet is ARP packet. If you see ARP packet, here in ARP packet, what is the source IP? Source IP is 192.168.1.3. Destination IP is 192.168.1.1. See here, destination IP is not 192.168.2.3. PC sending ARP packet to get the MAC address of default gateway. It is asking who is 192.168.1.1. Please give me your MAC address. I have some data I want to send you, like that. It is not asking who is 192.1.2.3 because 2.3 is a different network. To other network, PC cannot send the ARP packet. ARP packet only within the network, right? So now first this PC sends this ARP request. So you click on here, play symbols, play controls, right? Click on here, right? Now switch will do broadcasting. See, now this time router will respond because it is a 192.1.1.1, right? See here, this is the ARP replay, ARP packet. Source MAC address 98, sorry, source MAC A801. A801 is what is the MAC address? This interface MAC address, F050 MAC address. I will show you here in the router. How to see MAC address? Show interface F050 command. Show interface F050. See, A801 MAC address. So router is responding. Yes, I am the 192.1.1.1. This is my MAC address, like that. So send here and send here. Now switch first to update this information in the ARP table, and then it will forward the ICMP packet. See, it is going ICMP packet. Again it will send like this. Again it will send like this. Again like this, right? This is how ARP works between the networks. Very, very important in the interview. Okay, I will write here important points. When PC sends data to another network, source PC requires default gateway MAC address. Remember this point. If source PC doesn't know default gateway MAC address, it will generate ARP request to get the MAC address of gateway. Remember this point, very, very important. And one more important point, note. Interview question. When we are sending packet from one network to another network, what is the source IP, what is the destination IP, and what is the source MAC, and what is destination MAC? This is interview question. So source IP is sender IP, common, right? Destination IP is receiver IP, and source MAC is sender MAC, and destination MAC is gateway MAC address. Remember this, very, very important in interview. This is how ARP works within the network and between the networks. That's all guys about this topic. So if you have any doubt, if you have any query, please write in your comment. Okay, so I will respond, okay, to your questions. Thank you.